Okay, 19 says express in terms of sums and differences of logarithms. Um, and also you should express answers without exponents. So I kind of forgot that part, but it should be simplified all the way, expanded all the way out. So you're going to use multiple rules here. Now, the first one I'm going to start with is the fact that I've got division going on here. So I'm going to use the quotient rule first, which says log, and I don't see a visible base, so that means it's base 10. It's going to be log of the numerator, which is 9x to the 5th, minus the log of the denominator, which is y to the 6th. But then on that first log, these two things are multiplied. So for that one, I'm going to split it up. Okay, so for the division, I did this subtraction. And now for this multiplication, I'm going to use the product rule, which says it'll be the log of the 9 plus the log of the x to the 5th. And then still minus the log of y to the 6th. Kind of need a little more room here. And then I'm going to use the product rule because I have an exponent here and an exponent there. So they're going to have to go out in front so that my final answer is the log of 9 plus 5 times the log of x minus 6 times the log of y. That's a lot of logs. And I'm done with 19. 20 says, given that log base a of 2 equals that number, and log base a of 3 equals that number, and log base a of 4 equals that number, find log base a of a 24. Okay, there's more than one way to work this problem, but we're looking for log base a of 24. And so somehow you got to break the 24 down into factors of, let me get some different colors here. How about orange and purple? Purple. Oh, orange and purple. Here we go. You have to break it down into 2s or 3s or I guess I'll just use a darker green. Here we go. Or 4s. Now 24, I could break that down to 4 times 6 and then the 6 to 2 and 3. Or you could do 2 times 12 and then the 12 is 2 times 6 and then the 6 is 2 times 3. So you've got 2 cubed times 3. It doesn't matter. On my handwritten answer key, I actually broke it down to, I broke my, hello. I broke this down to be 4 times 6 and then the 6 to be 2 times 3. And then I used the orange, the purple, and the green with the product rule only. So I saw this as, when I saw the log base a of 24, I said, nope, that's going to be the log base a of 4 times 2 times 3. That is this factorization right here. And then I broke it down, because they're all multiplied, I used the product rule, which says, if you're multiplying, when you break it up, you add them together. And then I was just like, well, let's see. Log base a of 4 was right here, and that was 1.386. And then I'm going to add that to log base a of 2, which is here, and that's 0.693. And then I'm going to add that to log base a of 3, which is here, which is 1.099. And I added that all together to get my final answer of 3.178. Now that's the way I did it on my handwritten answer key. You could have over here instead, you could have said, okay, this is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. And then what you've got is a 2 cubed times 3. So let me come back up here where there's space so I can show you what I'm doing on this one. This version. I would see it as log base A of a 2 cubed times a 3. So that would be log base A of the 2 cubed plus log base A of the 3. And then you've got this exponent, so the exponent goes out in front, making this 3 times log base A of 2 plus log base A of 3. So that's going to be 3 times log base A of 2 was the orange, so 0.693 plus log base A of the 3 was the purple. But if you do all this math according to order of operations, you multiply first and then add second, you're going to get this same answer. So it doesn't matter which way you do it. It works both ways. Okay. Let's see. Express as a single logarithm and if possible simplify. All right, we're just going in reverse. If you have any coefficients on the logarithms, which I have right there, that's going to have to go back up to its exponent spot here. So the first thing I'm going to do is write this as log base C of Q raised to the 6th power minus log base C of R. And then, because there's subtraction going on here, when you condense it down to the single logarithm, which is log base C, it's going to be a division. You're going to divide, and the stuff in front of the subtraction sign, this stuff here, that'll be your numerator. And the stuff behind the subtraction sign, that stuff will go here. So I'll have a Q to the 6th over an R. And then 22 is another subtraction, right? So, but they're using natural logarithms. So you're just going to start with, okay, it's the natural log of the x squared minus 4 is my numerator, and the x plus 2 is my denominator, because this is the quotient rule. But the numerator is a difference of 2 squares. You can factor that to be x plus 2, x minus 2. And then the x plus 2 in the numerator cancels the x plus 2 in the denominator. So that all you're left with is the natural log of an x minus 2. And yes, you do have to have parentheses around the x minus 2. If you don't, then what you have is the natural log of x minus 2. But what we really have is the natural log of x minus 2. Did you hear me? All right. I'm going to stop.